I'll welcome you to PEG Tutors. Here we peg you on your route in all the science subjects. So, but today we are going to be working on mathematics. Prior to this time, if you want to add numbers normally, let's say you have number like this and they say add up. Simply what you do is you add 8 plus 3, that gives you 11. You don't drop the 11. They say drop 1, carry 1. And then you come here, 7 plus this is 9 plus 1, that makes it 10. You now drop 10 here, so it will be 101. Normally that is a normal addition, but I want to ask, probably you never knew what you were doing while adding 8 plus 3 giving you 11, and you drop 1, carry 1. That's what they taught us in school, basically, that you drop 1, you carry 1, not telling us why you are dropping 1 and carrying 1. Anyway, the reason is because the normal operation, the normal world accepted operation is base 10 system of operation. So we have always been using a default system of operation, base 10. And beyond that, majority of us does not know what we are doing. And under base 10, no number beyond 9 exists. So you have under base 10 from 0 to 9. So also we have other bases, like we have base 2, base 3, base 4, base 5, base 6, base 10, base 11, base 12, base 13, and any base you can ever think of. So apart from operating under base 10 alone, we can also operate in other bases, and that is why we are here. We have base 2, and base 2 system, numbers that exist under base 2 are just 0 and 1. 2 does not exist under base 2. In fact, any base you're operating on, the number on that will never exist on the base. So let us list out the bases we do have. So we have base 2 system. So if we have base 2 are only 0 and 1. Base 3, 0, 1, 2. So let's jump to base 10 system. Okay, let's jump to base 9. So under base 9, you would have, and beyond this, no one exists again. Now the question is, I first mentioned that you can also operate in base 11, base 12, base 15, base, all that. But you know that the normal natural number are just from 0 to 9. The rest numbers are repetition of what has already existed between 0 and 9. So apart from 0 to 9, no other number exists. Alright, so in bases, if you go beyond base 10, I think there is no way you can have 11, 12 as a normal number, because they are all repetition. So the only thing we do is this. So let's assume we are having from base 11 upward. We have base 11. Now I cannot write 10 as 10 because 10 has already existed before. So instead, numbers beyond 10, we represent them with alphabets. So from base 11, we have 0 to 10. So what do we use to represent 10 is the question. So 10 becomes A in the number alphabet. So we use A like this to represent 10. Base 12. And your guess will be as good as mine. If I ask you to complete base 15, you would tell me it's 0 to 9, then A, B, C, D, E. You are correct. So that is this for all the bases that exist. Now, since we are programmed to work on base 10, the question now is, can we convert from base 10 to other bases? Yes, it is possible. So let's assume you were given a value in base 10 and you are asked to convert it to other bases. Example, let's take number 1. Would be converting from 90 base 10 to 2, to a number in base 2. So what would the value be? The value 90 to base 10 be when you convert it to base 2. What do we do here? We constantly divide the value in base 10 by the base you are converting to, and at the end of the day we'll be noting the remainders. All right, let's start. So just draw a line like this, write your 90, which is the base 10 number, constantly divided by 2. So you have this 90 divided by 2 will give you 45, and of course remainder 0. 2, we go to 45, 22, remainder 1. Then 2, we also go into 22, and that will give us 11, remainder 0. 2 also will go into 11, that will give us 5, remainder 1. 2 we go into 5, that will give us 2, remainder 1. And then 2 we go into 2, that will give us 1, remainder 0. Then 2 we go into 1. Of course 2 cannot go into 1, so you can keep it 0, remainder that 1 that is here. So at the end of the day, count your numbers from down up, that's from bottom to top. So therefore, you can say therefore 90 in base 10, 90 in base 10 would give us 1011010, 1011010 to base 2. So equivalent of 90 in base 10 would be 1011010 in base 2 system. Let us take a second example. So this is another example too. Now I want you to solve it. You can pause and solve. So pause it and solve. Okay, so now let's see if you got it correctly. So we have this, we have this. So this is 50, and we are converting to base 3. Now here we go. 3 into 50, and that will give us 16, remainder 2. Now 3 in 16 would give us 5, remainder 1. 3 in 5 will give us 1, remainder 2. Then 3 in 1 will give us 0, remainder 1. So as usual, take your number upward. So we'll be having, therefore, 50 base 10 would be equal to 1212 base 3. So this is our answer in that. So you can see we are converting from base 10 to other bases now. So how do we convert this? As usual, you know what to do. Draw this, put your 100, which is the value in base 10. Then you have 5 here, dividing all through. So you have 5 into 100 will definitely give you 20. So remainder 0, of course. So 5 into 20, that will give you 4, remainder 0. Then 5 into 4, 5 cannot go into 4, so just put it 0, remainder 4. Take it upward, and you can say therefore 100 in base 10 would give you 400 in base 3. That is our answer. So check my next video to get the conversion from other bases to base 10. Please do not forget, subscribe to our YouTube channel, like, comment, and please, the number is there on the screen. My number is there on the screen. If there's a topic you want us to treat urgently, just put a call across or a message, and then we'll treat it very well. Thank you.